Okay, welcome to the class. Today we'll be starting with the four position synthesis of crank rocker mechanism. In the previous class, we have studied the three position synthesis where the crank and the rockers will be having three precision points. Based on these precision points, we have synthesized the mechanism. Okay, so similarly, we will be doing for four position synthesis. Four position synthesis. So directly we'll start with the problem and I'll explain you the procedure to be used for the construction of this particular mechanism. Synthesize a linkage. So synthesize a linkage to generate a function y is equal to log x to the base 10. So the function is y is equal to log x to the base 10 for a range 10 greater than less than equal to x less than equal to 60. So this is the range for x. Okay, we need to know the angles, the input crank range and output range. So input crank range, so input angle range is 120 degree. Input angle range is 120 degree and the output angle range is 90 degree. As we are doing the four position synthesis, n will be 4. Okay, so based on this, the same procedure remains initial cases, that is analytical solution for finding out the precision points and precision angles remain same, only there is a change in the construction part. Okay, so as we all know that for finding out the precision distances, delta xj is equal to delta x by 2 into 1 minus cos pi into 2j minus 1 divided by 2n. 2j minus 1 divided by 2n. This is the formula for finding out the precision points. Okay, so similarly we'll be doing it. So delta x1 will be equal to delta x. So delta x will be 60 minus 10. So what will be delta x? Delta x is 60 minus 10, so which will be equal to 50 degrees. So 50 divided by 2 into 1 minus cos pi. So as we are finding out the first precision point, it will be 2 into 1 minus 1 divided by number of precision points are 4, so 2 into 4. So when you solve this, we will be getting the values 1.903. So 1.903 will be the delta x1. So similarly, you have to find out delta x2. So delta x2 will be the same formula, 50 by 2 into 1 minus cos pi. 2j will be second one, 2 into 2 minus 1 divided by 2 into 4. So when you do this, we will be getting 15.43. So we'll be getting as 15.43 the value. So that is delta x2. Similarly, we'll be finding delta delta x3. So 50 by 2 into 1 minus cos pi into 2 into 3 minus 1 divided by 8. So when you solve this, we will be getting delta x3 as 34.56. So 34.56. So finally, we will be finding out delta x4. So it will be 50 by 2, okay, into 1 minus cos pi into 2 into 4 minus 1 divided by 8. Okay, so this is the solution. So delta x4 will be, delta x4 will be 48. So this will be 48. Okay, so this is the values of deltas. So we need to find out the values of x. So that is the precision point values. So we'll be solving that. So x naught, which is given as 1, okay, so we'll just write it down, not 1, it is 10, so it is x naught is 10, x1 we need to find out, x naught plus delta x1, the incremental change, so which will be 10 plus 1.903, so which will be 11.903. So similarly, you have to find out what is x2 and what is x3. So x2 is x0 plus delta x1, which is 10 plus 15.43 should be equal to 25.43. Okay, so x3 is x0 plus delta x3. Okay, sorry, this is delta x2. x3, so it will be 10 plus, what is delta x3? It is 34.56, which will be equal to 44.56. Okay, so similarly x4 we need to find out, which is x0 plus delta x4, which is 10 plus 48, we will be getting 58. So these are the values of precision point. So x5 will be 60. Between these we have got the 4 precision points. So we will be calculating what is the values of relative y. Relative y values we need to calculate. So we got the relationship y is equal to log of x to the base 10. Okay, y is equal to log of x to the base 10. So for y naught, it is log of 10 to the base 10. So we'll be getting it as 1. We'll be getting it as 1. So similarly, y1 will be log of 11.903 to the base 10. So we will be getting it as 1.075. 1.075. So y2 will be log of 25.43 to the base 10. So we will be getting the values as 1.40, 1.40. y3 is log of x3 y3, log of 44.56 to the base 10. Okay, so you will be getting it as 1.65, 1.65. y4 will be log of 58 to the base 10. So we will be getting it as 1.76, 1.76, and y5 is log of 60 to the base 10. So we will be getting 1.78. So 1.78. So these are the relative y values for the independent variable x1, x2, x3, x4. So we will be getting the relative dependent variables, that is y1, y2, y3 and y4. So based on these we need to calculate the angles. Okay, so we will be calculating the angles. So based on this, so First we'll be calculating the input angles. So input angles. So we know the formula for that. Ij is equal to delta xi upon delta x into xj minus x1. This is the formula for calculating the input angles. Here we are calculating the input angles with respect to a reference, that is initial angle we'll be considering it, and we'll be writing the input angles with respect to the first position. So all the angles will be considered with respect to the first position. Based on this, so if I consider the input range is given as 120. Okay, what is the range of x? X is 50 degree. Xj means x2 minus x1. So we are finding out xi12. Okay, if I'm trying to find out xi12, this will be the formula, that is 120 upon 50. X2 is 25.42, and y is 11.9. So y is 11.9. So you will be getting the xi12 as 32.5 degree. So similarly, you have to find out the xi13 and xi14. So you will be getting the input angles. Okay, so xi13 will be delta xi upon delta x into x3 minus x1. That is 120 divided by 50 into what is the value? 30. X3 is 44.56 minus 11.9. So we will be getting the angle as 78.38 degree. So xi13 is 78.38 degree. Okay, so after that we will be finding out xi14. So xi14 is similar, delta xi upon delta x into x4 minus x1. So delta xi is 120 divided by 50 into x4 is 58 minus 11.9. So we will be getting the angle as 110.6 degree. So this is xi14. Okay, so these are the input angles we need to remember. Okay, and we need to use these values to plot the angles. Okay, so next we'll go for the output angles. So similarly, how we have done for the three position synthesis, so we'll be doing the same thing here. So phi ij. So if I consider phi as the output angles, okay, so it will be delta phi upon delta y. Okay, so into yj minus y1. Okay, so 1j I'll take. Okay, so here delta phi is 90. Okay, so what is delta y? Delta y is y5 minus y0. So what is y5 value here? 1.78, 1.78, y naught is 1, so your delta y will be 0.78. So delta y will be 0.78. So 90 divided by 0.78 into y1 minus y2 minus y1. So 90 divided by 0.78 into what is y2? Y2 is 1.075 minus 1. So we will be getting 512 as 38.17 degree. So 38.17 degree. So this is the first output angle which we have got. So similarly we will be calculating phi 13, that is delta phi by delta y into y3 minus y1. Okay, so 90 divided by 0.78 into y3 is 1. Sorry, I have made a mistake here. Y2 minus y1, when you are taking y2 minus y1, it should be 1.40 minus 1.075. So it should be 0.75. So 1.4. Y2 is 1.4. Okay. So Y3 here is 1.65. 1.65 minus 1.075. When you do it, we will be getting the value as 67 degree. So we will be getting the values as 67 degree. So 514, if you do it, it is delta phi by delta y. So it will be y4 minus y1. So when you do this, 90 divided by 0.78 into what is y4? Y4 is 1.76. Y4 is 1.76 minus 1.075. 1.075. So we'll be getting it as 80 degree. So 80 degree we are getting. So this is 514. Okay. So I hope this is clear regarding the calculation of input angles and output angles. So these are the three angles which we need to remember, and we need to plot it in the construction. Okay, so when you plot the input angles and the output angles, automatically the construction is done, and we will be getting the crank rocker mechanism for these particular 4 precision points. Okay, so we'll start with the construction here. Okay. First what we did is here, first we have drawn the horizontal axis. After this horizontal axis, what we did is we plotted this A1, A2. So initial angle is 32 degree here. So what we did is we try to construct a symmetrical angle. So 16 degree above, 16 degree below, we try to draw it. Already we know the crank position as 4 centimeter. Okay. So 4 centimeter is the crank position. So with respect to this 4 centimeter, we drawn 16 degree line. And the output angle is 19 degree here, the first output angle. So on the other side, it should be 19 degree. Okay, I'll explain here. Other side should be 19 degree. But we don't know the position of this rocker. For that case, what we did is, sum of the angles of the triangle is 180 degree. We took it. So 19 plus 16 is 35. Okay. So 180 minus 35 is 45 degree. So what we did is, with respect to this point and this baseline, we draw a 145 degree line until it passes through this horizontal axis. When it passes through this horizontal axis, same here, horizontal axis, we get a point called as O4. We get a point called as O4. After this, what we did is, we just drawn the symmetrical. So this is the symmetrical triangle we drawn it. So after that, we got the values of another two input angles. One is 78 and one is 110 degree. So with respect to A1, I have drawn a 78 degree angle. With respect to A1, I have drawn 110 degree angle. So with respect to these two, I got these two positions, that is A3 and A4. So when you get this A3 and A4, you just mark these A3 and A4 points. After that, you have to join this A3 to O4 and A4 to O4. So after doing this, you have to take this as a center, okay, and O4, A3 as a radius. You have to just draw an arc. So here also O4 as a center and O4, A4 as a radius. You have to just draw an arc. So after that, what you have to do is, we need to plot these other two angles, output angles. One is 513 67 degree, 514 80 degree. So what you have to do is, keep this as a center and A3 as a reference line. You have to orient this line by an angle 67 degree. So when you do this line, okay, it will come here and you have to extend the line in such a way that it passes this A3 arc. So when it passes through this A3 arc, you will get a point called as B3. So similarly, keeping O4 as a center and O4, A4 as a radius, you have to just pass an arc, okay. And after that, O4 as a center and O4, A4 as a base, you have to orient this line by an angle 80 degree. By an angle 80 degree. After doing this, you have to extend the line until it passes through B4. Until it passes through B4. That is this arc, and this point will be B4. Next, what you have to do is, you have to join A1, B3 and B3, B4 straight line. Okay, you have to just join the points here. So you will be getting the points A1, B3 and B3, B4. So after doing that, you have to draw the perpendicular bisector. More than half, cut it. More than half, cut it. You will end up at this particular point. When these coincide at a particular point, I will be naming that as a B1 point. So your required mechanism is O2, O4, B1, A1. So O2, O4, B1, A1 is the required crank rocker mechanism. So you need to measure the values of that, or the dimensions of those links. So initially we have assumed O2, A1 as 4 centimeters. Okay. So then you have to measure the other 3 lengths. Okay. So like this, you need to construct the crank rocker mechanism for a 4 position synthesis. Okay. I hope it is clear. So we will be now studying one more method, which is called as an overlay method. Okay. So overlay method, we are not doing any constructions here. We will try to analyze the procedure, how it has been followed. Okay, the procedure how it has been followed here. See here, in a overlay method, we are trying to roughly identify the link length of a particular crank rocker mechanism. So in your 3 position and 4 position synthesis, you have already calculated the input angles like 512, 513, 514. Like similarly, if I go on increasing the precision points, the construction becomes a tedious job here. Okay, for that case, what they have done is they have developed a method for a higher precision points. We will be using a method called as overlay method. So in this overlay method, they will be using 2 sheets. Okay, 2 sheets. One will be a normal sheet, one more will be a tracing paper. Okay, one will be a tracing paper here, tracing paper, and one more is a plain paper, So what we'll do is first we'll try to locate the crank position. In a plain paper, we'll try to locate the crank positions. Okay, we'll assume the what we call it as the crank length, and we'll try to draw the different positions of the crank. Okay, we'll try to draw the different positions of the crank. So understand this, in a plain paper we'll identify a point, and with respect to the point I'll try to draw the different position of the crank. Okay, so after this I'll take this as a center. Okay, I'll take this as a center with the random, understand this as a center with a different radius. I'll try to draw the arc. So what is this means is this is a coupler length. This is a coupler length. I don't know the coupler length. Okay, so what should be the coupler length? I don't know. I'll just draw the different arc positions. Okay, so in the tracing paper, once again I'll mark the point. And I'll draw the different crank positions. Okay, these might be the radiuses of the crank position, the rocker positions. So in one paper I'll draw the crank positions, and what we'll do is, with respect to the different crank position, taking these as the centers, I'll just pass an arc of different radius. I'll just pass an arc. So on the other paper, which is called as the tracing paper, I'll try to draw the rocker positions, different angle rocker positions, which we have calculated from the precision points. Okay, it might be the first position, second, third, fourth, like this. We'll be drawing this different positions. So we'll be having this arc. So what we do is, later we'll take this tracing paper, we'll keep it on the plain paper and try to match these radius. Okay, I'll try to match these radiuses. So for first, this will be the angle. Okay, so I'll try to place it on the tracing paper. If any of the radius matches with this particular position, I'll take, for example, if it matches with the third position, so the tracing paper is here, so you will be getting this as the required mechanism. I'll be placing tracing paper on the plain paper and try to match the radius of the coupler. If any one of the radiuses gets matched, I'll mark that point. That point will be the coupler point with respect to the rocker. So this point and the crank point will be joined, and you will be getting the required 4-bar mechanism or the crank rocker mechanism. Okay, so what we have done, in a plain paper we have drawn the crank positions, okay, and taking that as the crank extreme positions, taking that as the center, and we have drawn the different radiuses arcs for the coupler. On the other tracing paper, what we have done, we have taken the rocker positions by drawing an arc at different angles. So I'll take this tracing paper and place it over the plane paper until any one of the radiuses perfectly matches. Where it perfectly matches, I'll just mark that particular point, and whatever the mechanism we are drawing it, that will be your 4-bar mechanism. So this is how an overlay method is being done. Okay, so we are not practicing this in this particular syllabus. Okay, only how the procedure is done is there for your syllabus. Okay, in the next class we will be starting with the analytical solution. So how we did it for the graphical solutions, the same way we will be doing the analytical solutions by using some formulas, mathematical equations. We will be trying to calculate the values of different links or the link lengths. So based on that, the method basically are two types of method. We call it as the Freudenstein method and as well as the Bloch method. So we'll be seeing that in the